So hi guys, welcome to the new session. In today's session, we are going to speak about the piecewise function. In the last session, we spoke about the identical functions. Okay, so piecewise functions. So basically, we need to understand what was the need to introduce piecewise functions. Piecewise function is nothing, it just means breaking the complex function into the simpler functions. Okay, uh, for example, we know modulus function x. Now, to solve this function, we need to break it into two, two simpler pieces, x minus x, right? So we know for this x, it is going to be x if here x is greater than equal to 0, and it's going to be minus x if x is less than 0. And then we know that if x is negative, then negative of negative, it's still going to be positive. Okay, so basically, this is a complex function, so that's why we just broke it down into two different pieces, right? So same, whenever we come across the complex functions, we try to break it down into simpler things, and then we work independently on those simpler things. The most common example, or the most the example that we use in everyday life. Okay, so it is your getting the parking ticket. Okay, if let's see here that getting the parking ticket, it is a function of time. Why? Because it depends on how many hours you are going to park your car in the parking lot. That will decide the amount of money you have to pay or they charge you. Okay, so it says that if you park for less than 3 hours, then you have to pay $10. Okay, and if you park for more than 3 hours but less than 5 hours, then you have to pay $15. Okay, now the question is that if you have to park your car for 15 hours, okay, then how much money are you going to pay? Okay, so what we did, we just broke this function down into the multiple pieces, and which will give us more understanding of how to count the money if we have to park our car in the lot for 15 hours. Okay, so here up to 5 hours, it's simple. Up to 5 hours I have to pay 15. So 15 hours, it means $45. Okay, but if for, let's say that here for 9 hours, okay, for 9 hours how much I have to pay? So for first 5 hours, yes, I have to pay $15. And then how many? Now see here, 9 hours, so here plus 5 times t is going to be 9 minus 5, right? So it's going to be 15 plus, and you are charging $5 per hour, so it's going to be for next 4 hours, it's going to be $20, right? So the total would be your $35. I hope you agree with it. Why? Because after 5 hours you are charging $5 per hour. That's what it says, that if number of hours will exceed 5, then they are going to charge $5 per hour. If your t is 6, then it means for 1 hour they will charge $5. If t is 7, means for 2 hours they will charge 5 times 2, 10. Okay, so when we divide this whole complex function into the pieces, then things get easier. Okay, so same here, when we deal with the functions, complex functions should be uh, we should break them down into the simpler ones. Okay, so now we will have more clarity on the piecewise functions through examples. uh, First example is fx equal to mod x, right? Now, see here, fx equal to mod x. Now, see here, the behavior of this mod x, if you look at it, now it's going to be x if here x is going to be greater than equal to 0, and it's going to be minus x if x is less than 0. right? Or in other words, here I can say if your x belongs to, it's going to be, in other words, I can say that it's going to be x for all x belongs to 0 to infinity, and minus x for all x belongs to minus infinity to 0, right? So what we did, we just divided, or we just broke it down into two pieces for better understanding of the domain, right? One more example is fx equals x square minus 1, right? X square minus 1. Okay, now see here. So fx equal to modulus function x square minus 1. So now how this modulus function is going to behave? Now, as a whole, it's very complex thing and very complex approach to see this function as a whole. Better if we break it down into two pieces. First is, this is going to be x square minus 1 if your x square minus 1 is going to be greater than equal to 0, and here it's going to be 1 minus x square if your x square minus 1 it is less than 0, right? So from here I can say that if x minus 1 and x plus 1, it's going to be greater than equal to 0, and from here x minus 1, x plus 1 less than equal to 0. Okay, so if I just draw a number line here, 2 points, minus 1, here 1, right? So for greater than 1, in this interval, this is going to be positive, positive, right? Positive, positive. So positive, this one negative, this one positive. Here I'm using baby curve method. Okay, I have made a separate video, right? Or we have a separate session on baby curve method or sign change scheme. You can go through that. Okay, so here it's going to be greater than equal to 0, so it means that your x belongs to minus infinity to minus 1 union 1 to 1 to infinity. Why here? Here close bracket y, because it's greater than equal to 0, and here less than 0, not less than equal to 0. That's what the definition of modulus says, right? So here less than 0 means this area, right? So it's going to be minus 1 to 1. X belongs to minus 1 to 1. Okay, now you can see here, now you have two different domains, right? And things got easier when you broke it down into two different pieces, and then you got separate domains. Now we have better understanding of the function, we have better understanding of the domain, okay, which otherwise would not have been possible. Okay, uh, let's take one question. Let's see if we can crack it. Okay, got this question on the internet, which I found interesting, and I can relate it to piecewise function. It says that your ABCD is a square of side L, line parallel to diagonal BD at distance x from vertex A cuts two adjacent sides express area of segment of square with A at a vertex S function of x, find area at x equal to 1 by root 2 and x equal to 2 when L equal to 2. Okay, now see here, this is the question, and you can relate the whole situation to the piecewise function. Okay, how? See here, it says that ABCD is a square. Okay, this is a square. Okay, A, B, C, D. I'm making two squares here because it's going to be a piecewise function. So here we have to think of two cases. Okay, and now we know that the diagonals of the squares, they make 90-degree at the center, right? But BD, it's given. Okay, so BD is given, that's why BD is solid. Okay, now line parallel to diagonal BD at a distance x from vertex A. Now see here, it says that we have to draw a line parallel to BD at a distance x from this vertex. Now, he didn't mention here whether this line falls on this side or this side. So we will take two cases. So that's why it's a piecewise function. Here we are breaking things, complex thing, because we cannot think of this thing as a whole. So we have to take two cases. So let's see that in this case, one line parallel to BD at distance x is this. At distance x is this. And the other line BD, okay, the other line parallel to BD at distance x will be this. Okay, I hope this is visible to you. Okay, now, and it cuts two adjacent sides. Okay, so it is cutting two adjacent sides, right? Now we have to express area of segment, means that we have to express the area of this segment and the area of this segment as function of x. Okay, now first of all, see here, we have to find the area of these two segments, right? Now, first of all, what we need to see here is that this is the length L, right? This is the length L. Now, if this is L, okay, see here, first thing is solution, and solution says that side of a square equal to L, right? So if this is L, this has to be L, it means then AC, right? AC is going to be, then your AC is going to be root of L square plus L square, and it's going to be L root 2. I hope you agree with me. And here, this point is O, this point is O. Here, this is C, D, E, F, right? This is C, D, E, F. Right? So AC, we got it, which means that from here, I can say that AO, right? equal to AO equal to OC is equal to AC by 2. Why? Because this is the middle point, right? So it's going to be L root 2 by 2, which is L by root 2, right? And these two diagonals, they bisect each other, so that's why divided by 2. Now we have to find out the area of this segment. Okay, so this is your case 1. Okay, case 1, area of segment, or area of triangle AEF, area of triangle AEF. So what it's going to be, right? Now, see here, this is your 90 degree, right? If this is your 90 degree and this is already 90 degree, it means this is 45 degree, right? And this is 90 degree too, means it is 45 degree too. Okay, if that happens, which means that this is also 45, so it's going to be right angle isosceles triangle. So which means that here this side, it's going to be equal to this side, and this side, according to the symmetry, it's going to be same as this side. So here G, I say this is G. So here I can say that here what I know, that AG is X, and EF it's going to be 2x. Why? Because this is going to be same as this, because this is a right angle isosceles triangle and these two sides have to be equal. So your area of triangle AEF, it's going to be half into base is going to be 2x multiplied by height, which is going to be x. So your area, it's going to be x square, right? Now come to the case 2. Case 2. Now in case 2, you have to find this area of segment. So this area of, what is it? This is going to be your it's going to be your what? Pentagon, right? How many sides? 1, 2, 3, 4, 5. Yes. So area of your 1, 2, 3, 1, 2, 3, 4, 5, right? So A, B, E, F, D. Okay, so area of your pentagon ABEFD, it's going to be the area of, this is what we need to find. So how can we find it? Area of square ABCD minus area of triangle FCE, right? FCE, right? If you delete this triangle from this square, then you will get this pentagon, right? So which is going to be, now come to the area of the square, this is going to be L square, right? And area of your FCE, now come here again, this is your 90 degree, this is your 90 degree, so it means it's going to be your 45 degree, it's going to be your 45 degree too, right? And this is your this length OC, it is your OC is your L by root 2. So what we can do here is this is X, right? Now see here, I need to find this let's say this is point FG, this is point G, right? This is point G. So I need to find this GC. So here, GC, can I say GC is going to be your AC minus GC is going to be your AC minus AG, right? AC minus AG. AG, I know it is X. And what is AC? AC is L root 2. So my GC is going to be L root 2 minus X, right? And I know this is also the right angle isosceles triangle. So this is going to be similar to this, right? So this EF, it's going to be 2 times L root 2 minus X, right? So this area, first sort out this area. Okay, L square minus, this is going to be 1 by 2 multiplied by EF multiplied by GC, which is L square 1 by 2. EF is 2 times L root 2 minus X, and GC was L root 2 minus X. So your this is going to be your area. It's going to be your L root 2 minus X square. Now see here, we have two cases. So here I can write my area of segment here X square. When X square, it's going to be 2X square when for all x belongs to, for all x less than, for all x less than AO, right? AO means this, right? L by root 2. And it's going to be this one, L root 2 minus X square for all x belongs to, sorry, x greater than L by root 2. Why? Because if x is greater than this, then this line must fall in this region, right? So here, see here, piecewise function. Now we have to find area at x equal to 1 by root 2 and x equal to 2 when L is 2. So when L is 2, when your L is 2, what would happen? Okay, now see here, when your L is 2, when your L is 2. Now, if you put L2, what will happen? So this is going to be your 2. It's going to be your root 2. And here, 2 greater than root 2, right? Now, you have to find area at x equal to 1 by root 2. Now, 1 by root 2. X equal to 1 by root 2 means, what does it mean? Now see here, this is 1 by root 2 means 1 divided by, what is the value of root 2? 1.414. Okay, so it means that this is going to be less than 1, right? Which means that this, right? So x equal to 1 by root 2. So we have to apply this condition. So here it's going to be 1 by root 2 square, which is going to be 1 by 2. Okay, and x equal to 2. X equal to 2, it means that we have to follow this condition. Why? Because x is 2 means greater than this. So here L was 2, so it's going to be 2 root 2. So 2 root 2 minus 2 square, right? You can further simplify it. Okay, so you can just apply the formula. This is going to be a square, which is going to be, or you from here 2 common 4, and here inside root 2 minus 1, right, square, right, which is equal to, this is going to be 2 plus 1 minus 2 root 2, right, which is 4 here 3 minus 2 root 2. Okay, so you can simplify it further. Okay, but the whole point is that here, see here, we got two piece of functions. Now we need to find area at x equal to 2. So x equal to 2 means that they are talking about this domain, and x equal to, sorry, x equal to 1 by root 2 means they are talking about this domain. So we have to use function according to that. I hope this whole session, it has explored new way of thinking when we deal with the complex functions. Okay, so in the next lecture we are going to discuss few more functions. Have a great time. See you. Bye bye.